In this lesson, I want to talk about three things, two definitions and how those definitions connect to each other. The first one is something called a secant line. Now here we have the graph of y is equal to x squared. It's scaled a little bit differently, but 0 squared here is 0, 1 gets mapped to 1, and 2 goes to 4. I'm going to put 2 points on this equation, one at 0, 0, and the other at 2, 4. Now, a secant line is just a fancy way to say we can draw a line between these 2 points. Very easy to do. You just need to know the slope. You can use one of the points, and you'll get your equation. So I'm just going to graph that equation now. So here it is. I could have picked any 2 points, but this blue line represents the secant line between the 2 given points. Now, what if you don't have 2 points and you're just given 1 point? So I'm going to remove this secant line, and I'm going to remove the point 0, 0. But what if you just have 1 point? Can you draw a line here? And the answer is yes. You're going to use something called a tangent line. So that's our second thing. So a tangent line is different than a secant line because it's only going to go through this 1 point, but it's going to move in the direction of the equation. So what do I mean by that? Like, for example, if a particle was traveling along this curve held by a force, and then all of a sudden at this spot the force were to let go, the particle would leave the path but start traveling tangent to the equation. So what I'm going to do is now put a tangent line at this point on the curve. So it's going to look like this. So notice that, it looks like there's a little overlap, but that's because, we're probably too zoomed out. But this line, it goes through exactly this 1 point and is moving in the direction of the curve. So that second part of the definition is important because, let me put a different line on here. Like, for example, here's a line that goes through the 1 point, 2, 4, but is definitely not moving in the direction of the curve. So we would say that this thing is not a tangent line, but this is. So those are the first two things, two definitions. A secant line, which I'll put back up here. A secant line is something that goes between 2 points. And a tangent line goes through 1 point of the equation traveling in the direction of the curve. So the last thing is, how do these two ideas connect to each other? The way they connect to each other is, you can approximate a tangent line with a secant line. I'm going to put that point at 0, 0 back. If I start moving this point closer to this point, the secant line will look very, very close to the tangent line. So I'm going to first move this point to 1, 1. Then I'll move it to x is equal to 1.5, and then maybe 1.9. And we should see this equation getting closer to this one. So let's check that out. So I'm going to move the point that was at 0, 0 over to x is equal to 1. And notice that as the point is moving closer to the one at 2, 4, the two lines they're not the same, but they're closer. If I now move it to x is equal to 1.5, it's still not the same, but the equations are approaching each other. Maybe I'll stop at around, 1.9 or something like that, and the equations are very, very close. And the second that I get to 2, 4, the secant line goes away, and that's because for a secant line you need 2 points, and now the 2 points overlap. But if you back up just a little bit, the two lines are very close to each other. I'll now put this back to 0, 0. So just to recap, we had a secant line that went between 2 points. We had a tangent line that goes through 1 point. And as you move the 2 points closer together, we have that the secant line starts approaching the tangent line.